Welcome to This Explainer. I am absolutely thrilled you're here today because, well, we're going to embark on a really interactive journey straight into the inner workings of your own mind. We're pulling back the curtain on how your brain actually processes the world around you. We'll be looking at the science of your invisible biases. You know, those quiet, behind-the-scenes shortcuts your brain takes every single second of the day without you even realizing it. So prepare to be surprised, because today, the subject of our experiment is literally you.
But right before we really get going, let's make a little bet. And don't worry, I'm not after your money. I'm betting against your confidence. In the next few minutes, I'm going to show you just how incredibly easy it is to completely fool your own brain. And honestly, here's the scary part. You're probably going to fall for at least one of the tests I'm about to show you, even after I've explicitly warned you that a trap is coming. No way, right? Well, ready to test your mind? Let's begin.
Okay, let's dive into this. Section 1. The logic traps. System 1 in action.
We're going to start with some rapid-fire scenarios just to see how your brain handles sudden problem-solving. Here's your first test. Listen carefully. A bat and a ball cost $1.10 in total. The bat costs exactly $1 more than the ball. So, how much does the ball cost? I want you to pause for a second, be totally honest with yourself, and just lock in your instinctive answer. Got it? Is it like the vast majority of people, your brain just shouted 10 cents? It feels perfectly right, doesn't it?
Well, let's playfully break down this instinct versus reality. If your instinct was right and the ball costs 10 cents, and we know the bat is exactly $1 more, then the bat would cost $1.10. Now add those together. $1.10 plus 10 cents equals $1.20. But wait, our total was supposed to be $1.10. See, your brain just completely jumped the gun. It saw $1, it saw 10 cents, and it just kind of split them up without doing the actual calculation.
Gotcha. The actual mathematical reality is that the ball costs 5 cents. Think about it. If the ball is 5 cents, the bat is exactly $1 more, which makes the bat $1.05. Add $1.05 and 5 cents, and boom, you get exactly $1.10.
So why did your brilliantly capable brain just fail basic elementary school math? Because your mind absolutely loves fast answers. Psychologists actually have a specific term for this: System 1 thinking. This is the part of your brain that's quick, highly intuitive, and completely automatic. It's incredibly efficient for navigating daily life, but as we just saw, sometimes it's flat out wrong.
Let's see how this builds into our second test. Which of these scenarios is more likely? Option A, a woman is a bank teller. Or option B, a woman is a bank teller and active in the environmental movement. Go ahead, lock in your answer. Now, option B feels much more detailed, doesn't it? It paints a vivid picture, it feels realistic, and because of that, most people immediately choose B.
But mathematically speaking, option B absolutely cannot be more likely than option A. Think about it for a second. Every single environmental activist, bank teller in the world is already included in the larger, broader category of just bank tellers. By adding another condition that she must also be an activist, you've actually shrunk the pool of possibilities, which makes it statistically way less likely.
And this brilliantly illustrates what psychologists call the conjunction fallacy. Your brain fundamentally prefers a good, detailed story over cold, hard logic. A specific, vivid story just feels true to us, even when the underlying math screams that it's less likely. At the end of the day, we're story-driven creatures, not calculators. Moving right along to Section 2, the perception traps, how we see the world.
Now, these invisible biases extend way beyond trick math questions. They actually shape how you perceive reality and make sense of the world every single day. So, here's your third test. Which of these two cities has a larger population? San Diego or San Antonio? Now, don't Google it, just trust your gut and guess. I'm willing to bet you leaned pretty heavily towards San Diego.
Why did you pick San Diego? Well, because you've heard of it more often. It's in movies, TV shows, tourism commercials. It simply feels more familiar to you. But the actual answer, the real truth, is San Antonio. Our brains have this super sneaky habit of automatically mistaking familiarity for truth.
This phenomenon is known as the availability bias. Basically, if a piece of information comes to your mind easily because it's highly available in your memory, your brain takes a shortcut and just assumes it must be more likely, more common, and more correct. It's a total mental blind spot that confuses easy to remember with factually accurate. Now, what's truly fascinating about this slide is how easily we can be manipulated by things that have absolutely nothing to do with the problem at hand.
Imagine you watch a random wheel spin, and it lands on the number 65. Then you're immediately asked to estimate what percentage of countries in the United Nations are in Africa. You don't know, so you guess. But if a completely different person watches that exact same wheel land on the number 10, and they're asked the exact same question, their estimate will be drastically lower. The wheel is completely random. It has nothing to do with Africa. Yet it drastically alters their geographical guess.
This is a classic demonstration of the anchoring bias. A completely random, totally irrelevant number is placed in your mind, and it quietly pulls your actual estimates toward it. Think about how massive the implications of this are in your own life. I mean, this happens every time you walk into a store and see a limited time discount, or when you're negotiating a salary or buying a house. The first number thrown into the room literally anchors your brain, whether you want it to or not.
Let's try another super relatable scenario. Imagine you upload a video online and you get 100 comments. 97 of them are overwhelmingly positive. 2 are neutral and just 1 is negative. Looking at this breakdown, which comment do you think you're going to be obsessing over all day? Exactly. You're going to completely ignore the giant bar of 97 positive comments and focus entirely on that tiny, single negative one.
This is the negativity bias at work. Your brain is hardwired to treat bad information like it's an absolute emergency. There's a brilliant quote from our source material that perfectly captures this. Compliments arrive and leave, criticism moves in and pays rent. Your brain holds onto the negative because, well, historically speaking, ignoring a threat was a lot more dangerous than ignoring a compliment.
Let's look at one final test of perception, the attractive stranger. Imagine you're looking at 2 people. One is incredibly attractive, highly confident, and charismatic. The other person looks completely ordinary, maybe even slightly awkward. Instinctively, without knowing anything else about them, who do you assume is more intelligent? Who's more competent? Who's more successful? Most people instantly hand all these positive traits right over to the attractive person. And we do this without a single shred of actual evidence. This is called the halo effect. When we see one exceptionally positive trait, like good looks or charm, it creates this glowing halo that spills over into everything else. In our minds, good-looking automatically becomes smart. Confident automatically becomes capable. Successful automatically becomes trustworthy. Your brain just cheerfully fills in the blanks to complete the positive picture. Which brings us to Section 3, why we fool ourselves. It's not stupidity, it's evolution. So, having gone through all these tests, you might be feeling a little, well, tricked. You might have even known about some of these biases beforehand, and yet there's a very good chance you still fell for at least one of them today. But I want to be very clear. Falling for these traps is not a sign of stupidity. Failing these tests is simply a side effect of having a normal, functioning human brain. So the crucial point is that your brain was never actually designed by evolution to be perfectly mathematically rational. It was built for survival. It was designed to make incredibly quick decisions while operating on very limited information. And honestly, most of the time, that speed is incredibly useful. It literally keeps you alive. But sometimes that exact same speed creates these highly predictable mistakes we've been talking about.
Which brings us to the absolute most important takeaway of this entire explainer. The real experiment isn't some math trick about a bat and a ball. The real experiment is your daily life. Every single day, while you aren't looking, your judgments are being quietly shaped by first impressions, by the size of the font in news headlines, by the first price you see on a car lot, by social media algorithms, and by feelings of fear and familiarity. And the really tricky part is, you usually can't even see these biases while they're happening.
So, I want to leave you with a challenge. For the rest of today, and hopefully tomorrow too, whenever you find yourself making a quick judgment or forming a really strong opinion, I want you to pause and ask yourself this one simple, powerful question. Is this reality, or is this just my brain taking a shortcut? Because the very moment you start questioning your first instincts, you instantly become a whole lot harder to fool, even by yourself. Thanks for joining me on this mind-bending journey, and keep questioning what you see.